Let us try to understand some overview of satellite communication system. A majority of communication satellites are in geostationary Earth orbit with an altitude of 35,786 km or nearly 36,000 km. Typical path length from an Earth station to a geostationary satellite is nearly 38,500 km. Now, radio signals get weaker in proportion to the square of the distance traveled. So, signals reaching a satellite are always very weak because of this large distance. Its distance is really high. Similarly, signals received on Earth station from a satellite 38,500 km away are also very weak because of limit on the weight of geosatellites and the electrical power they can generate using solar cells. Costs roughly $25,000 per kilogram to get a satellite, geostationary satellite obviously, in orbit. This obviously places a severe restrictions on the size as well as weight of geosatellites. Since the high cost of building and launching a satellite must be recovered over a 10 to 15 years lifetime by selling communications capacity. In the early days, very large receiving antennas with diameter up to 30 meter were needed to collect sufficient signal power to drive video signals or multiplexed telephone channels. But nowadays the situation is little bit different because of uh, high performance antennas are now present. We can design high performance antennas, so the size of the antenna are not this much nowadays. As satellites have become larger, heavier, and more powerful, smaller earth station antennas have become feasible. And direct broadcast satellites TV, that is DVS TV receiving system, can use these antennas as small as 0.5 meter in diameter. We will now consider frequency band designations. The range of frequencies is 0.1 to 0.3 gigahertz, that is called the very high frequency or VHF. Our FM broadcasting system are using this particular range of frequency. Now 0.3 to 1 gigahertz, this range is called the ultra high frequency range or UHF range. Mobile communication system, that is 900 megahertz mobile communication system, they are using this particular range of frequency. Next one is the 1 to 2 gigahertz range, which is called the L band. Our GPS system, they are actually using this L band. Next band is 2 gigahertz to 4 gigahertz. This particular band is called the S band. Bluetooth or microwave oven, they are actually using this particular range of frequency. Next one is 4 gigahertz to 8 gigahertz. This particular range is called the C band. Generally, satellite communication system uses this particular range of frequency. Next band is 8 to 12 gigahertz, that is designated as X band. This particular range of frequency is reserved for experiment purpose, laboratory experiment purpose. 12 to 18 gigahertz, this particular range is called the KU band. Nowadays, satellite communication system, uh, they are using this particular range of frequency or this particular band. Next, 18 to 27 gigahertz, this is called the K band. K band is also useful for satellite communication system. Next one is 27 to 40 gigahertz, which is called the Ka band. Now this Ka band may be useful for radar system. Next one is the 40 gigahertz to 75 gigahertz, which is called the V band. V band may be used for inter-satellite link or ISL communication system. Next 75 to 110 gigahertz, which is called the W band. That particular band is also useful for radar communication as well as remote sensing purpose. Next band is called, basically we are not showing uh, those bands. We actually starting from 110 gigahertz to 300 gigahertz as millimeter wave band, but we can still uh, divide this particular range of frequency into several bands. We are not showing it. This millimeter wave band can also be useful for radar system or remote sensing purpose. 300 to 3000 gigahertz, this huge band, this huge range is actually called the micrometer, and we are not going to give you very brief idea about what is the utility of that particular band, but nowadays this particular band is very much useful for night vision uh, camera or night vision system design. Now we'll try to understand the frequency band designation as per ITU. So 3 to 30 kilohertz, this range of frequency is called the very low frequency or VLF. Well, this particular range of frequency is useful for uh, submarine communication because lower range of frequency can pass through the saline water. That is why this particular range of frequency is useful for uh, submarine communication. Also, they are useful for sonar. Next band is the low frequency band. Its range is 30 to 300 kilohertz. This band is also useful for marine communication. Next band is the medium frequency band (MF). Range is 300 to 3000 kilohertz. This particular range of frequency is very much useful for AM broadcasting system. High frequency band or HF band is from 3 megahertz to 30 megahertz, and this particular range of frequency is very much suitable for shortwave radio broadcasting. Next one is the VHF or very high frequency, 30 to 300 megahertz. FM signal, FM broadcasting system, they are actually using this particular range of frequency. Next one is the UHF or ultra high frequency range, that is 300 to 3000 megahertz or 3 gigahertz. This huge range, actually lots of applications are there like mobile communication, GPS, Bluetooth, etc. Next one is called the super high frequency or SHF, ranging from 3 gigahertz to 30 gigahertz. So satellite communication system using the super high frequency. Next one is extreme high frequency or EHF, that is 30 to 300 gigahertz. And remote sensing, radar, they are actually using this particular range of frequency. And 300 to 3000 gigahertz, actually this range is, we don't call this particular range as radio frequency. They are actually uh, termed as infrared region. So we are not going to that part. Well, satellite systems operate in the microwave and millimeter wave frequency bands using frequencies 1 and 50 gigahertz. Now, above 10 gigahertz, rain causes significant attenuation of the signals, and the probability that rain will occur in the path between the satellite and an earth station must be factored into the system design. Above 20 gigahertz, attenuation in heavy rain, usually associated with thunderstorms, can cause significant attenuation that the link may fail. Now, for the first 20 years of satellite communication system, analog signals were widely used, with most links employing frequency modulation. Obviously, wideband FM can operate at low carrier to noise ratios C by N that we have already understood from FM technology in the 5 to 15 dB range, but adds a signal to noise improvement so that video and telephone signals can be delivered with signal to noise ratios of 50 dB. The penalty for the improvement is that the radio frequency signal occupies a much larger bandwidth than the baseband signal. In satellite links, that penalty results because signals are always weak and the improvement in signal to noise ratio is essential. But nowadays, the situation is completely different. Now we have digital system, and most of the systems, they are actually using digital technology like telephony, data, DBS system, radio broadcasting, and navigation with GPS all use digital signal technique. All of the LEO and MEO mobile communication system, LEO means lower Earth orbit and MEO means medium Earth orbit. They are using digital link, taking advantage of voice compression techniques that allow a digital voice signal to be compressed into a bit stream at as low as 4.8 kbps. Similarly, MPEG-2, that is moving picture coding expert group, and other video compression techniques allow video signals to be transmitted in full fidelity at rates less than 6.2 Mbps. This is actually showing a typical direct broadcasting system. Suppose this is the studio where the signal is generated, video signal or voice signal, whatever may be. Then this signal is transmitted via this relay station, and it is relayed to the actual broadcasting station, where the signal is transmitted via this uplink antenna towards the satellite. So the signal is now going to the satellite. So satellite receives the signal and then it broadcasts, or we can say it relays the signal within a certain locality. So it may be individual reception in normal households, or it may be community reception. So one receiver will be there, and that receiver will receive the signal from the satellite and it will distribute over within that particular region. All the houses will be covered by this particular receiver. So this is a typical system.